The aim of the experiment is to simulate pulse width modulated signal for different modulating signal voltage amplitudes and modulating frequency. Pulse width modulated signal is a train of pulse of different width. The width of the PWM signal varies with the instantaneous value of the modulating signal. If we compare the sawtooth wave and the modulating wave, the sawtooth wave acts as carrier and modulating wave is a message signal. So when we compare them, wherever the modulating signal is greater than the sawtooth, the output of the train of pulse is positive, else it is negative. Thus the message is carried in the width of the pulses. Let's go to Matlab and start the coding to generate a pulse width modulated signal. I have an octave online. We'll start from the origin. Let's take t is equal to, I'll start from 0 to 1 second with interval of 0.001. If Fm, the modulating frequency, is taken as 1, Fc, carrier frequency, is taken as 10, the amplitude of the carrier is taken as 1, and the peak amplitude of the modulating wave is taken as 0.75. The equation of the sawtooth wave is S is equal to sawtooth AC sawtooth to pi F M T. Modulating signal M is equal to AM sine 2 pi FM. It was FC. I have to repeat this. S was FC sawtooth is equal to AC into sawtooth. S is equal to sawtooth 2 pi FC. Sawtooth is a carrier wave. So FCT. Whereas M is my modulating wave. M is equal to AM into sine 2 pi FM T. Now it's fine. Let PWM be denoted with the matrix here. All the data will be here. PWM PWM I have to let n is equal to the length of my sawtooth signal, length of S, and PWM is equal to that's right, I should have defined n before. So I'm using for loop for comparison. For I is from 1 to n outputs, and if m of I is greater than equal to S of I, then PWM of I is equal to 1. Else PWM of I is equal to 0. I end it, and now plotting part is left. Subplot 2, 1, 1. I'll have just 2 graphs. In one graph, I would like to have both the modulating as well as the sawtooth. So I'll use this command plot. I like to plot both of them together, T comma M in the blue color or red, and T comma S, and let this be in blue. So I'll write axis also. So it is between 0, 1 to say minus 1.5 to 1.5. Title, message, and sawtooth signal. Okay. And now I want to subplot the subplot 212. Plot P goes off PLOT plot T comma PWM title, pulse width modulated signal, axis, zero, 1 is the along x-axis, and the y-axis is minus 0.5 C to 1.5. Some axis. Oh, yeah, 1.5. Yeah. And then complete it with the X label and Y label. X label is time, Y label, Y label is amplitude. Okay. So this completes the experiment. As we see, the above graph shows the modulating signal and the sawtooth in one graph. So for comparison, it's done whenever the modulating signal, which is in red color, is greater than the sawtooth. We see the pulse width modulating signal has a positive amplitude, and elsewhere it is negative. Thus we see the width is varying. The width is maximum when the amplitude of the modulating signal is maximum. The width is minimum when the modulating signal has the minimum value. Thus, the message is carried in the width of the pulse train. We end this experiment here. Thank you.